Welcome back. In this video, I will show you how to write code in C for Inorder Traversal in binary tree. In one of the previous videos, I have shown you how to create a binary tree in C like this. This is the code for creating the new node for inserting into the tree, and it should be called like this. Root is your pointer, which is pointing to the root node of the tree, and executing these codes, a tree will be formed like this. As in the previous videos, we will use the same binary tree for Inorder Traversal. Now this is our tree and here is a stack. These are the addresses we have used before. This is our structure. This is our insertion operation for creating the binary tree. And this is our main. As we have done in case of pre-order traversal, we are using the same codes here. Here is a stack here with size 20. Here we have taken 7 cells only because this stack is enough to hold a small tree like this. You set root to null. The duty of the root pointer will be pointing to the root of the tree. Here is your choice variable for this menu, and you set top to 0 here, and you set stack top to null here, and then you run this while loop for your traversal. Now you must ask your user to create a tree by pressing 1, and whenever the tree will be created, the root pointer will be pointing to the node at 781 because this node is the root of the tree. Now we move to choice 2. We declare a popped item pointer that will hold the address of the popped item from the stack. We also have a PTR pointer that will be pointing to the current node. Initially, PTR and popped item will be set to root like this. Now, why we have initialized popped item to root? This variable popped item can take 2 values, null and not null. Not null may be left child, right child, root, or current address. Now, out of these, popped item is meant for holding only current node's addresses. So, it is safe to initialize popped item to root. This is the do while loop, and this loop will run until we get a popped item that is equal to null. At first, we check whether PTR is null or not. If PTR is not null, so this if block will work, and there is an else block where we will handle when PTR is null. Now here you see that PTR is not null, that is, it is standing at 781, so we get inside, and here top is incremented by 1. So top goes to 1 now. Then stack top equal to PTR. That means you store PTR's address to stack top. That is 781 comes over here. And you set PTR to PTR left. That means PTR is 781 and its left is 513. So PTR comes down over here. The loop runs because popped item is not null. So top is again incremented to 2. Stack top equal to PTR, so 513 comes over here, and PTR is set to PTR left like this. Again, you find PTR is not null, so increment top, and 233 will be coming over here. And then you set PTR to PTR left, so that PTR becomes null now. We will handle this situation in the else part. So this red block is the else part here. Within this else block, there is another if-else set here, and this inner if-else will check whether the popped item is null or not. If popped item is null, then if block will execute, and if popped item is not null, then this else block will execute. Now we go to the first line of this else block. Item is popped from the stack and stored inside the popped item. So stack top is 233. So 233 will be coming inside popped item. Top goes down, and then we will check whether the popped item is null or not. We see that popped item is not null. So this else block will be executed. PTR is set to popped item. The PTR is null now. It will be set to 233. You print the data. This is our processing port. And standing at 233, you check whether there is a right child or not. You run this while loop. While PTR right is null, then these three statements will be executed. And if ptr write is not null, that is the case here, then we will have an if condition. So after this while loop, you will write the if condition here, because there is no space actually, so I have written over here, right? Now if ptr write is not null, that means there is write child. What we should do? Set ptr to ptr write. That means ptr is at D, its write child is F at 449, so ptr will be set to 449. After this, you check whether popped item is null or not. So popped item is 233, it is not null. So we move to the if condition in the beginning of the do while loop. For our convenience, I have copied that portion over here so that we don't have to move to the previous slide repeatedly. Now, ptr is not null. It is standing at 449. So this if block will be executed. If ptr not null, then increment top, store the ptr to stack top. So top will be incremented, 449 will be stored inside the stack, and set ptr to ptr left. So ptr again becomes null here. Now we check this while condition, popped item is not null, really it is. So we run this do while loop again, and you find that ptr is null. So this if block will not fire now, this else block will fire, this red else block. There, item will be popped from the stack and it will be stored inside the popped item variable. So stack top is 449. So 449 comes over here, top goes down, and then within this else block, we have this if else pair where popped item is checked whether it is null or not. We find that popped item is 449, that is not null. So we run this else block here, and there it is written set ptr to popped item. So ptr is null now, it will be set to 449. You may print the data or whatever processing you require. Then standing over there, you check whether there is write child or not. This time you see that there is no write child. That means ptr write is null. So this while loop will be executed now. While ptr write is null, then pop item from stack and store it inside popped item. So 513 is the topmost element inside the stack. So 513 comes over here, top goes down, and then set ptr to popped item. So ptr will be set to 513 now. After setting ptr to 513, you process the data again. Standing over there at 513, you check whether ptr write is null or not. You say that ptr write is not null. So this if block will be executed, and it is written ptr is set to ptr write. So ptr is at B, that is 513, ptr will be set to 716. Now this cycle is over. You say the condition is true, that is popped item is not null, that is 513. So this do while loop will run again. You see here ptr is standing at 716. So this if block will be executed because it is not null. So store the ptr's address to stack top, increment top, and store the 716 over here, and then set ptr to ptr left. So ptr left goes like this, so that ptr becomes null now. Your popped item is 513. So this do while loop will run again. This time, this if block will not be executed because ptr is null. So this else block, that is a red block, will be executed. Within this red block, the first statement is pop item from stack and store inside popped item variable. So the topmost element is 716. 716 comes over here and top goes down. And then you check within the inner if else block whether popped item is null or not. It is not null, that is 716. So this else block will be executed. Within the else block, the first statement is set ptr to popped item. So ptr is null now, popped item is 716, so ptr will be set to 716. You may print the data, and then standing over there, you check whether the ptr's write is null or not. we find ptr's right is null. So this while loop will be executed now. Pop item from stack and store inside popped item. So topmost element is 781. This will be stored inside popped item. Top goes down to 0 and then set ptr to popped item. So set ptr to 781 here and then you may process the data. After this, you should check whether there is a right child or not. If there is right child, that is ptr right not equal to null, set ptr to ptr right. So yes, there is a right child C at 291, so set ptr to 291 and this cycle is over. I will stop here and leave the rest of the steps for you. When the last item of this tree will be processed, null will come out of the stack, and for that we have given a check here that popped item is null. That indicates traversal is completed, and this break statement will stop the do while loop. This was the code for Inorder Traversal in a binary tree. In the next video, I will go for introducing post-order traversal in a binary tree. Thanks for watching and take care.